So graphing linear inequalities, we're looking at two variables, right? Y's and x's. So I recommend putting these in the slope-intercept form. Okay, so if it comes out in standard form, I'm going to change it to slope-intercept form, although you don't necessarily have to. You can work with the y and x intercepts if you prefer to. Just sometimes they're fractional and that kind of sucks. So we're going to change the equations into slope-intercept form because then we can graph the y-intercept and we can use the slope to find all the other points. That's the only two things you really ever need to graph a straight line, other than just 2 points. But since I'm doing it by hand, I'm going to show all the points. Now, like you're saying, is if it's less than or just greater than, remember, no equal parts, we're going to have it dashed or dotted, however you want to put it on there, because I'm doing it by hand. If it has the equal parts, so less than or equal to or greater than or equal to, then it's a solid line. The reason that is because then all the points on the line would be equal to, and that then would make them true statements. But the dotted line tells us the values on the line would then be false. But we need a line because that's a transition from falsefulness to truthfulness, okay? And that's where we need the third and fourth steps here. Choose a point on the either side of the line because we're going to test it. And then once we test it, if it's true, then we shade that side of the line. If it's false, we shade the other side of the line. So truth tells us shade. False tells us shade the other side. Maybe that's more confusing, but hopefully an example will help. So the shaded areas, whatever they are all true. All the points there, all the ordered pairs in that area are true. So again, we're looking at infinite values that make the infinite number of ordered pairs that make the inequality true. But the shaded part makes it so that we can communicate that easier and faster. Okay, so this is nice. They've given us the equation in slope-intercept form. So I know the 2 there is my slope, which I will show. I know I need my rise and run right there, right? So it's 2 over 1. The 2 is positive, so it'd be up 2. The 1 is positive, so that'd be to the right 1. Now, I probably should have started with the y-intercept, okay, because that's our starting point on the graph, which would then be 0, -1. Okay, now this is slope-intercept form. Y equals mx. M is the slope. Mx plus b. B is the y-intercept. It's a -1 because of the minus sign right there. So 0, -1. Let's go ahead and put that on the graph. 0, -1. There we go. And then I'm going to graph the rest. I'm just going to put points on there. I'm not worried about if this is solid or dashed yet. I'll get there. But I'm going to go up 2 to the right 1. So up 2 to the right 1. That's the next point. Up 2 to the right 1. And so I'm showing all the stair steps, although you don't necessarily have to, and most students don't when they're doing it by hand. Of course, on the computers for the assignments, you just got to put 2 points and it will graph the line. But now that I'm doing this by hand, I have all the points that I can put on the graph I've just got to worry about if my line will be solid or dashed. And I see I've got the equal part on the inequality there, so it's going to be a solid line, which again communicates that all the points on the line would make the inequality true. So let's see if, well, let's try some technology to help me out because I need it. That's better. There we go. Okay, so that's my line. It is solid and it's fairly pretty. But now that we have this on the graph, that's just the parts that make it equal. We now need to take care of the ordered pairs that would make the inequality portion, the greater than portion, a true or false statement, I guess. Now, if the line is going through the origin, you can't use that, but this one's not. So I know I'm gonna use the origin right there. It's just barely off the line, the origin at 0, 0. That's going to be my test point. So what I'm going to do is I'm going to go back to the original inequality. Y is greater than or equal to 2x minus 1. And then I replace the x and y with the x and y value that I've chosen from my test point. So the x value is 0 and also the y value is 0. We'll go ahead and solve this. And that will tell me if I need to shade on the side of the line, which for me I'd say this is to the left. Some people would say up, either way. But from this I get 0 is greater than or equal to -1. Now, from what I know, which isn't so much, but that's true, 0 actually is bigger than -1. It doesn't have to be equal to. In fact, we don't really care about the equal part because that's the green line right there. So since it's true, And my point, I would say, is on the left. That means I got to take my shading tool. Let's see if I can do this with less shading this, but there we go. This side of the line I just shade in. Now, I don't really have to get all of it because I'm just doing it by hand, but this tells us, again, every ordered pair that's on this side of the green line there would make the original inequality a true statement.